Have you guys heard of visual scripting before? I stumbled upon it while I was looking to see if there was an alternative to coding. That's when I found out about Unity's visual scripting. It works in the same way as code, telling the game how you want it to function, but instead of using code, it gives you a preset lines of code in nodes that you can connect together to make the game function. And I wanted to see if I can follow an entire course and finish a game without writing a single line of code. Probably best to start with a tutorial. Yeah, this looks pretty good. Finally, we move on to code pretty quickly in the course, and along with that was my first challenge. Before we get started, I should probably explain a few things. First, I'm a beginner. This is me actually learning in this video, so please take everything you hear with a grain of salt. Next is that visual scripting won't be able to exactly replicate everything normal coding does, but you can get pretty close, and that's what I'm hoping for. With that out of the way, let's get started with our first line of code. Pretty simple, I think. With this first line of code, he is using a variable to make the player's name Bob. Making variables in visual scripting is quite easy to do, and there are four types of variables or data types as used in code. Strings, which are used for words and text. Integers, which are for whole numbers only. Floats are for incomplete numbers such as decimal numbers. And Boolean for true or false statements. At least that's how I like to think about it. I should probably show you how we can make a visual script. You want to click on your game object, add component, and you want to type in script and select script machine. From here, you can create a new script which will be saved to your computer. Give it a name, something that you'll remember. I personally like to add prefixes SC to let me know that it's a script. And then once you have that saved into your computer, you want to click on edit graph. And you will be met with on start and on update. I will go over these here later in the video, but in order to add a variable, you want to go over to object, give it the name, player name, a string, and the data type, which is Bob. Now let's take a look at the second line of code, private void start. I will get into the public/private and void later in the series, but for now let's focus on just the start. That is a life cycle. A life cycle is something that happens that will trigger the script to start. In this case, it's the game starting by hitting the play button. So before the game starts, the variable that we had set up was Bob. If you remember, is this. We want the script to change Bob to Bob the hero and log that into the debug console. Once we see that, we will know that we did it right, and we can do that by adding a few nodes. Going back to that second line of code, we can add that start event by right-clicking, events, lifecycle, and on start. And underneath that's what we want the script to do. In this case, change the player name to Bob the hero. Here we have Bob, and the first thing we want to do is change it. So I'm going to put that away for now, and I'm going to get a new node called set variable. This is how you change variables. So we have the onStart event flowing into the set variable. We want to choose player name because that's the variable that we are changing, and then we want what we want to change it into. From here, you can just type in string in literal terms and change it to Bob the hero. Plug that into set variable, and that's it. Once the game starts, it changes Bob to Bob the hero. But we're not done. We still want to add it to the log. And in order to do that, we can right click, add node, and search up debug. This will be the final node in this primary string that I have here. And what is the message that we wanted to show up? Bob the hero started the game, if you remember. So what we can do is now we can get this variable of the player name, which has been changed to Bob the hero. We want to attach another string to it. Started the. And we want to combine these two, which we can do by typing in onCat string and make sure it has two object inputs. 1, 2. The top one will go in first and then the second one. We want to plug that into the message. And once we run this script, it should show up in the debug log. So let's take a look and see what happens. Save it real quick. Bob the hero started the game. Perfect. There you have it. However, we can clean this up a little bit more. If we go back to edit graph, you set the variable to Bob the hero, but you also get it here. We can actually take out the middleman and plug Bob the hero right in there. So all this does is change the variable to Bob the hero. And since we're just adding a message to the debug log that matches the variable, you could do get variable here, or you can just bring the literal string all the way through. Should still have the same effect. Let's take a look. There we go, Bob the hero. It's better to optimize your script because you have to remember we're going to have thousands of hundreds of nodes in our final game. And, you know, coding is sometimes thousands of lines long, and this is just 2, right? I want to take this a step further and have everything update with just changing the name in the variable. If you remember, the variable is right here. So when I stop playing the game, it changes back to Bob. But what if I want to change it to something else? Let's do Mark, for example. Just click play. Nothing's changed. But I wanted to change with me typing in Mark. So how would I go about changing that? We'll stop the game, go back to edit graph, and we're gonna change a few things. Instead of having Bob the hero string go all the way through straight into the message on the log, we want to change it so it updates with whatever name we have in the variable at the beginning of the game. So the way we go about that is we can delete this literal Bob the hero string, and we're going to get our original variable back again. In this case, Mark. We're going to combine it with the hero. So now this will be Mark the hero, and just plug that into the set variable, which would update it in the future. But now, how do we go about getting this updated into the log? Well, it's quite simple. Just drag it, and let's take a look and see what happens. Save, close that out, and we have Mark the hero started the game. And if my theory proves true, we put Chris the hero started the game. So how does this work? And do you notice anything out of the ordinary or anything odd? Have you noticed that the variable is throwing 2 different values out? First Mark, and then Mark the hero started the game into the log. How does that work? Let me show you. Up here there is a button called values. When you click on that, it kind of shows you what Unity sees. In this case, you can see that Chris the hero, combining it together and setting it to Chris the hero here, which sets the variable to Chris the hero. So now when we go on to the debug log, it pulls the new variable that has been updated into Chris the hero, started the game, and into the log. So with that, you're able to put in any name at the beginning before the game starts and have it updated throughout the entire game. Pretty cool, right? So now we can put any name that we like and have it updated for the next following start of the game. Moving forward, we add the additional variables that I mentioned earlier. These are the variables that Alex adds in his video. So we can go about it like this. We have the age variable. It's an int, and the data is 25. We have the move speed variable. It's a float, and the value is 2.5. And finally, the boolean, the game over variable, which is called game over, the boolean, and this is true or false, just by clicking the box here. Just like we added the string earlier, that's how you add new variables. Now, boolean is a new one. It's not like the other ones where it has a certain data set that we just plug in. It's true or false. And this is really important for games because it determines things like if a player has an item or a key, the status of a player if he's bleeding or poisoned, to see if it's true or not. We can also add components from Unity into our Visual Script by searching it up and adding it in the script menu. For example, we have rigid body 2D. There you go. Right now we don't have anything selected, but if we wanted to add something to it, I'll show you guys how to do that as well. Or life cycles, as I mentioned earlier. Do you guys remember that the game start event that is the life cycle? In Unity, there's an execution order. Pretty much what that means is the order in which things takes place. You can search this up by searching up the execution order. You'll come up across a website that looks like this. Now, this is too advanced for me to even comprehend what it all means, so I won't. I'll save that for a future me to figure out. However, I will go over the basics just like Alex did in his video. This is the next set of codes that we'll be trying to simulate using visual scripting. As you can see, we have private void awake, void start, void update, and private void fix update. All those are life cycles, and they all start at different times. Awake starts first, then start, then update, which updates every single frame, and then fixed update, which is on an interval timer around 50 times per second. The code that he has here, so whenever he starts a game in the console, it'll show awake has been called once, the start has been called once, and an update is being called for every frame. That you can see here in the console that he has on his video. The awake event is the very first thing that runs when the game starts. It runs before even start. But what's the difference? Can't you just have a really long script that does everything in the order that you want? And technically, I guess you can, but if you want to really optimize your game and keep things organized, it might be a good idea to learn the order of the basic life cycles and what they can be used for. For example, awake and start can be used to set up a game like spawn enemies and weapons, and update can be used to see in which direction you're moving. Now, if you remember at the start of the section, I had that meme that appeared because, well, there is no awake when it comes to visual scripting. However, while it's true that there is no awake, there is a workaround that we can use, and that is onEnable. OnEnable, it triggers when a game object becomes active, and since it's active from the very beginning, it triggers right when the game starts, and it even activates before the start event. So technically, it works. Using that knowledge, we can continue to simulate the code and see if it runs the same way. Let's save this and see if it works. As you can see, it's updating on every single frame. It worked perfectly. It worked. Functions are used to organize and reuse specific piece of code without having to type out the same thing over and over again. Think of them as little folders with code inside of them, and you can just call the function and it'll run whatever it is that you have inside them. There is no functions in Visual Scripts, kind of. We do have subgraphs, which work like functions, but before we get started, let's see what we're working with. Yeah, Alex created a function at the bottom. It's called getPlayerInfo. What it does is it puts the player's information in the debug log along with its variables. That's it. That's the function itself. If you look above, he calls that function on the awake event. So the game starts, it'll show the player stats on the log. How do we go about making this? Well, let me show you. First, we had to create a new variable called character level, an integer with a data of 80. Simple enough. Now that we have that, we can proceed to making the function in the subgraph. Create a subgraph, you want to right click, add node, nesting, and subgraph. This is your folder. You can access it by double clicking. Inside, we can put the script pretty much in the same way that Alex did in his video. The function itself is not very difficult. If you remember, it's very similar to the event code that we just did. All we have to do is put some string into the debug console. So how do we go about doing that? Well, first you can see there's 3 different kinds of variables that we have to connect with strings to put into the console. So first I'll add the debug console because I know there's going to be 3 of them. Next, we want to get our 3 variables that will play a part into this. It'll be the player name, player's age, and the character's level. We want to combine our variables with some string. Once we have all the strings available, we want to combine them with the variables. And once you have everything set up and organized, we can move things around to make it a little bit more cleaner. And there you go. This is how I would make the getPlayerInfo function inside of the subgraph. If you go back into the main graph, you can see we just have the folder here. How do we access it? Well, we have to put an input into the subgraph from the main script to access. There's a few different ways to do this. Best that I found was enter, but flow works as well. Let me show you how that works. If you go back into your folder, click on input, you do trigger inputs. From there, you go back into the main graph. You do see that now there is an input and a way to access the folder. You can also do an exit for an output, which I will show in a later video. So to see if this works, all we're going to do is we're going to unplug this by right clicking and on start into our function, which is our player's information. Be sure to grab from the enter flow and plug it in all throughout the debug logs. That way it shows up when we run the game. And there we go. Now, don't get too excited. This is just the beginning. I had a lot of fun making it, and this is part 1 of the series. I'll continue to watch and learn more about visual scripting, and I hope you guys are here along for the ride and to see if we can really make an entire game without writing a single line of code. Stay tuned and subscribe to see when I release part 2, which we're going to take a look into the differences between private versus public, as well as embedded versus graph, which I haven't talked a lot about here, but it's important to know as well, and new lines of code like taking damage.